Hello everybody and welcome back to another visual pattern challenge. Here is our pattern today. Here's step 1, step 2, step 3, and your challenge is to predict the number of green squares in step 4. This is a monster. If you can do that, can you predict the number in step 43? And can you write an equation that could be used to predict the number of squares in any step at all? If you'd like to accept that complicated challenge, pause the video and see how far you can get. All right, this is really big. And actually the first thing that I notice is that we have squares in here and it looks like maybe they overlap a bit. I think what I'm going to do is try to map out the biggest square I can see and then see what's left over. That's going to be my strategy. So I'm seeing a 4 by 4 square there, and I'm seeing a 5 by 5 square there. And is this 6? Yeah, this is 6 by 6. Okay, so the big central square is 4, then 5, then 6. So I would imagine it's going to be 7 by 7. Okay, so 49 squares in that part. Now what else happens? I'm going to ignore these two little ears. I think that's going to come at the end. It looks like we get 4 other squares with 1 square of overlap. So a 2 by 2, but with 1 square of overlap. So instead of 4 squares in that 2 by 2, there's 1 missing. But we have 4 of those patterns, and this is 2 by 2, and then 3 by 3, and then 4 by 4. So we're going to have 5 by 5 here. But since 1 is overlapping, we have to subtract 1. So instead of 25, it's going to be 24 in each of these. Okay, so 24 here, and 24 here, and 24 here. Okay, boy, these numbers are going to add up pretty quickly, I think. And then let's see, the only thing I haven't accounted for is these 2 little guys on the top, and it looks like they stay the same every time. So that's just a +2, so 1 up here and 1 up here. So what is all that? 49 and 96, because 24 times 4 is 96, and 2, I think this is going to be 147. Already in step 4, we're up to 147. Double check the arithmetic on that for me, but that's what I'm getting. And I think, counting is going to be tedious here. We'll do it just to verify, but I think I'm going to try to take a visual approach to coming up with an equation first, because we've drawn out all these squares. So I think we can make a reasonable guess at an equation. The big square in the middle is 3 by 3 in step 1, 4 by 4 in step 2, etc. So it's always 2 greater than, is that right? No, it's 4 by 4 in step 1, it's 5 by 5, then 6 by 6, so it's 3 greater. So this part is x plus 3 quantity squared. So that's the big central square in each step. And then the smaller squares, so let's just imagine those are full squares. It's 2 in step 1, it's 3 in step 2, so it's 1 more. So we're going to add the smaller squares. There's 4 of them, and it's just the step number plus 1. So x is standing in for the step number. So in step 1, this would be 1 plus 3, that's 4. That gives us this 4 by 4 squared. Here, 1 plus 1 is 2. That gives us the 2 by 2 squares. However, and I multiply that by 4 because there's 4 of them, but there's that overlap, which means 4 of those squares have to be taken away. So I'm going to put a -4 after that. And then we've just got these 2 squares on top left over, so that's a +2. So that's a lot. I think I am going to go ahead and FOIL all this out, distribute. Oops, I forgot the squared here. Distribute and try to simplify. So this would be x squared plus 6x plus 9. And this would be 4 times x squared plus 2x plus 1. And then -4 plus 2 is a -2. And let's see, distributing the 4. So we've got our x squared plus 6x plus 9 plus 4x squared plus 8x plus 4 minus 2. And we're going to have, let's see, we've got 5x squareds, and then 14 x's, and 9 plus 2 is 11 plus 11. So this is what I think our equation is. Why don't we take a moment to count the squares and then see if this is actually working. And we'll analyze the numbers while we're at it. So let me make a chart with the step number and the number of squares. This may take a moment to count all these. And I don't want to just look at the squares and multiply them, because that's really what I'm doing with this formula. I just want to count so that we're doing this, verifying it with a second method. So 4 and then 2, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 29, 30. So I'm getting 30 in step 1. Let's do the same here. So and I am getting 59 in step 2. Let me get to step 3 here. This is going to take a little while. Oh my goodness. Yeah. All right, you might want to double check this too, although we'll quickly see if we get a coherent pattern or differences. I think I'm getting 98 here. And then we are predicting 147 in step 4. So let's take our differences. 59 minus 30 is 29. 98 minus 59, what is that? 39. Okay, this is promising already. And 147 minus 98, that's 49. Okay. And then so we're obviously not getting a constant, because we know this is not a linear pattern. If we get a constant in the difference of the differences, then that verifies the quadratic. 39 minus 29 is 10, and 49 minus 39 is 10. So we did get that constant in the difference of the differences. So this is quadratic, and the coefficient of that x squared term is going to be half of this difference. Half of 10 is 5. That's exactly what we got here. So it looks like our analysis of the numbers verifies at least the first term of our equation. Let's actually plug this in for a couple of these. I won't do it for every one. But if we put in 1 for x here, that would be 5 times 1 squared plus 14 times 1 plus 11. And that is 30. Yeah, that's 30. Great. So that's what we got there. Let's just try it for 2 as well. So 5 times 4 plus 14 times 2 plus 11. So that's 20 and 28, 38, and 11, 59. Yeah. So we have definitely got a formula that seems to work here. You can test that with step number 3 if you like as well. But I'm confident that this 5x squared plus 14x plus 11 is an equation that predicts this pattern. And all we have to do is plug in 43 for x to get the number of squares in step 43. You probably want to take out your calculator for this one. So that is 5 times 43 squared plus 14 times 43 plus 11. Let's see, 43 squared is 1849. And what is 14 times 43? Oops, let me draw that a little more clearly. So 430, and then so 602, I think, and plus 11. And then 5 times 1849 is at 9245, and plus 613. I think I'm getting 9,858. So step 43 should have 9,858 squares. Well, how did that go for you? Did you get 147 for step 4? How did you tackle this monster? Did you try to get an equation from this visual, or did you analyze the numbers? I'd like to know. Thanks, everybody.